Abiogenesis, or informally the origin of life, is the natural process by which life has arisen from non-living matter, such as simple organic compounds. While the details of this process are still unknown, the prevailing scientific hypothesis is that the transition from non-living to living entities was not a single event, but a gradual process of increasing complexity that involved molecular self-replication, self-assembly, autocatalysis, and the emergence of cell membranes. Although the occurrence of abiogenesis is uncontroversial among scientists, there is no single, generally accepted model for the origin of life, and this article presents several principles and hypotheses for how abiogenesis could have occurred. Researchers study abiogenesis through a combination of molecular biology, paleontology, astrobiology, oceanography, biophysics, geochemistry and biochemistry, and aim to determine how pre-life chemical reactions gave rise to life. The study of abiogenesis can be geophysical, chemical, or biological, with more recent approaches attempting a synthesis of all three, as life arose under conditions that are strikingly different from those on Earth today. Life functions through the specialized chemistry of carbon and water and builds largely upon four key families of chemicals: lipids, fatty cell walls, carbohydrates, sugars, cellulose, amino acids, protein metabolism, and nucleic acids, self-replicating DNA and RNA. Any successful theory of abiogenesis must explain the origins and interactions of these classes of molecules. Many approaches to abiogenesis investigate how self-replicating molecules, or their components, came into existence. Researchers generally think that current life on Earth descends from an RNA world, although RNA-based life may not have been the first life to have existed. The classic 1952 Miller-Urey experiment and similar research demonstrated that most amino acids, the chemical constituents of the proteins used in all living organisms, can be synthesized from inorganic compounds under conditions intended to replicate those of the early Earth. Scientists have proposed various external sources of energy that may have triggered these reactions, including lightning and radiation. Other approaches, metabolism-first hypotheses, focus on understanding how catalysis in chemical systems on the early Earth might have provided the precursor molecules necessary for self-replication. Complex organic molecules occur in the solar system and in interstellar space, and these molecules may have provided starting material for the development of life on Earth. The biochemistry of life may have begun shortly after the Big Bang, 13.8 billion years ago, during a habitable epoch when the age of the universe was only 10 to 17 million years. The panspermia hypothesis suggests that microscopic life was distributed to the early Earth by space dust, meteoroids, asteroids and other small solar system bodies, and that life may exist throughout the universe. The panspermia hypothesis proposes that life originated outside the Earth, but does not definitively explain its origin. Nonetheless, Earth remains the only place in the universe known to harbor life, and fossil evidence from the Earth informs most studies of abiogenesis. The age of the Earth is about 4.54 billion years. The earliest undisputed evidence of life on Earth dates from at least 3.5 billion years ago, and possibly as early as the Orchian era between 3.6 and 4.0 billion years ago, after geological crust started to solidify following the molten Hadean Eon. In May 2017, scientists found possible evidence of early life on land in 3.48 billion-year-old geyserite and other related mineral deposits often found around hot springs and geysers uncovered in the Pilbara Craton of Western Australia. However, a number of discoveries suggest that life may have appeared on Earth even earlier. As of 2017, microfossils, or fossilized microorganisms, within hydrothermal vent precipitates dated from 3 77 to 4. 28 billion years old. Found in Quebec. Canadian rocks may harbor the oldest record of life on Earth, suggesting life started soon after ocean formation, 4 billion years ago. According to biologist Stephen Blair Hedges, if life arose relatively quickly on Earth, then it could be common in the universe. Subscribe our channel for more such informative short video.